The Coandă-1910, designed by Romanian inventor Henri Coandă, was an unconventional sesquiplane aircraft powered by a ducted fan, called the turbo-propulseur by Coandă. Its experimental engine consisted of a conventional piston engine driving a multi-bladed centrifugal blower which exhausted into a duct. The unusual aircraft attracted attention at the Second International Aeronautical Exhibition in Paris in October 1910, being the only exhibit without a propeller, but the aircraft was not displayed afterward and it fell from public awareness. Coandă used a similar turbo-propulsor to drive a snow sled, but he did not develop it further for aircraft. Decades later, after the practical demonstration of motorjets and turbojets, Coandă began to tell various conflicting stories about how his early experiments were precursors to the jet, even that his turbo-propulsor was the first motorjet engine complete with fuel combustion in the airstream. He also claimed to have made a single brief flight in December 1910, crashing just after takeoff, the aircraft being destroyed by fire. Two aviation historians countered Coandă's version of events, saying there was no proof that the engine had combustion in the airstream, and no proof that the aircraft ever flew. In 1965, Coandă brought drawings forward to prove his claim of combustion ducting, but these were shown to be recently reworked, differing substantially from the originals. Many aviation historians were dismissive, saying that Coandă's turbo-propulsor design involved a weak stream of plain air, not a powerful jet of air expanding from fuel combustion. In 2010, based on the notion that Coandă invented the first jet, the centennial of the jet aircraft was celebrated in Romania. A special coin and stamp were issued, and construction began on a working replica of the aircraft. At the European Parliament, an exhibition commemorated the building and testing of the Coandă-1910. Early developments. Coandă was interested in achieving reactive propelled flight as early as 1905, conducting tests of rockets attached to model aircraft at the Romanian Army Arsenal in Bucharest. In secret at Spandau in Germany, Coandă successfully tested a flying machine equipped with a single tractor propeller, and two counter-rotating propellers providing lift, powered by a 50 horsepower Antoinette engine, positioned along the fuselage centerline. The smaller rear lift propeller was mounted vertically, while the larger front one was inclined slightly forwards at 17 degrees. According to later claims, Coandă tested the aircraft at Kassel, witnessed by the Chancellor of the German Empire Bernhard von Bülow. It was around this time that Coandă's interest in jet propulsion began, claiming that the aircraft and a jet-propelled model were displayed in December 1907 at the Sport Hall Indoor Sports Arena in Berlin. Coandă continued his studies at Liège, Belgium, where together with his roommate and friend Giovanni Battista Caproni he built the Coandă-Caproni box glider, based on the plans of gliders designed by Otto Lilienthal and Octave Schnut, which he previously studied at Charlottenburg and Spandau. In 1909 he was employed as technical director of the Liège Spa Aero Club, and at the end of that year, with the help of car manufacturer Wikipedia, he built the Coandă Wikipedia glider. Caproni was present when the glider was flown at Spa-Malchamps, Belgium, 1910s. With the opening of the École Supérieure d'Aéronautique et de Constructions Mécaniques on 15 November 1909, Coandă moved to Paris. As a continuation of his Belgian experiments, and especially looking for a way to test wing airfoils at higher speeds, he contacted Ernest Archdeacon, the co-founder of l'Aéroclub de France, who in turn directed Coandă to Gustave Eiffel and Paul Paye main levee. With their assistance, he gained approval to test different wing configurations and air resistance on a platform built by Eiffel at the front of a locomotive on the North of France Railway. In March, he started flying lessons at Reims in a Henriette monoplane. Helped by his school friend Camerata Adornine, Coandă started to build his slender sesquiplane and the unusual power plant in a workshop in the courtyard of his house, where he tested the thrust of the power plant on a dynamometer, tests which are described in detail in the April 1910 edition of La Tecnica Aeronautical. He filed for several patents for the mechanism and aircraft on the 30th of May 1910, with later additions to the existing patents. Coandă exhibited the aircraft at the Second International Aeronautical Exhibition held from the 15th of October to the 2nd of November 1910. Together with Henri Fabre's Hydravion, the first floatplane, Coandă's aircraft and devices used for aerodynamic experiments were placed in solitary state in an upstairs gallery, separated from the more usual types of aircraft on the main exhibition floor. The aircraft's construction was a novelty for the time. In contrast to the monoplane described in the July 1910 patent application, the exhibit was a sesquiplane which complicated the construction, but in return solved lateral stability control issues. The cantilevered wings were held in place at 3 points by tubular steel struts without any bracing from flying wires. According to Coandă's description, the wings were built with metal spars, but existing photographs of the construction show a completely wooden internal structure. The trailing edges of the upper wing could be twisted separately or together for lateral control of braking during landing, and were controlled by pedals in the two-seat open cockpit. The fuselage, painted reddish-brown and highly polished, was described by the Technical World magazine as having a framework of steel, though the construction photographs indicate that it had a wooden framework. This was triangular in cross-section with convex ribs edged with strips of steel, and strengthened with a covering of heat-shaped molded plywood. Tubular radiators for engine cooling were located on either side of the cockpit. The vertical struts from the wings were secured to the fuselage with steel collars fixed with screws. The fuselage terminated in a cruciform empennage with control surfaces at 45 degrees angles to vertical and horizontal. 4 triangular surfaces at the rear of the tail were controlled using a pair of large Antoinette 7-style steering wheels mounted outside of the cockpit, one on each side, and were used for pitch and directional control. It was an early instance of what are now known as ruddervators. Forward of the tail was a small horizontal stabilizer. The fuel tank was located in the fuselage between the engine and the cockpit. The most remarkable feature of the aircraft was its power plant. Instead of a propeller, a 50-horsepower inline water-cooled internal combustion engine built by Pierre Clerget at the Clement Bayard workshop with funding from Aeronautical, France, placed in the forward section of the fuselage, drove a rotary compressor through a 1-to-4 gearbox, which drew air in from the front and expelled it rearward under compression and with added heat. The compressor, with a diameter of 50 centimeters, was located within a cowling at the front of the fuselage. According to later Coandă descriptions, cast aluminium components were also made by Clerget to create a power plant with a weight of 1.8 kilograms per kilowatt, equivalent to a power-to-weight ratio of 0.59 kilowatts per kilogram, a considerable achievement at the time. Coandă's 1910 patents described the inline piston engine's exhaust gases as being routed through heating channels or heat exchangers in contact with the central airflow. then sucked into the compressor inlet to reduce back pressure on the engine while adding more heat and mass to the airflow. The turbo-propulsor was claimed to be capable of generating 2.20 kilonewtons of thrust. The power plant was referred to in reports at the time by different terms: a turbine without propellers, turbo-propulsor, ducted fan, or a suction turbine. Aviation reporters from the Aero and La Technique Aeronautical were doubtful that the power plant could provide sufficient thrust. The engine was noted in the Aero, reprinted in Aircraft, as being of remarkably small proportions in relation to the size of the machine. The writer said the turbo-propulsor was claimed to give an enormous wind velocity, but the intake area seemed too small to produce the stated thrust, and that it also appears as if enormous power would be necessary to drive it, more than supplied by the Clerget. The Coandă-1910 was reportedly sold to Charles Weyman in October 1910. A daily newspaper from Bucharest wrote in 1910 that the aircraft was constructed in Clerget's workshops and that it will fly in 6 to 7 weeks near Paris. Piloted by Weyman, one of the pilots celebrated at the Rennes aviation meeting. Another Bucharest newspaper listed the aircraft in November as sold twice over. It may be that Weyman expressed his willingness to buy the aircraft once tests had been carried out. At the exhibition, reaction among observers was mixed. Some doubted the aircraft would fly, and focused on more likely machines such as the Sloan, the Voisin, or Louis Paul Hand's design. Others gave special notice to the Coandă-1910, calling it original and ingenious. The reporter from La Technique Aeronautical wrote, "In the absence of definitive trials permitting the precise yield of this machine, it is without doubt premature to say it will supersede the propeller. The tentative is interesting and we watch it closely." The official exhibition report ignored the turbo-propulsor engine and instead described Coandă's novel wing design, and the unusual empennage. On the 15th of November 1910, L'Aeronautical wrote that if the machine were ever to develop as the inventor hoped, it would be a beautiful dream. After the exhibition, the aircraft was moved to a Clement Bayard workshop at Issy-les-Moulineaux for further testing. This work is reflected by additions to the power plant-related patents of the 3rd of December. A group of modern-day Romanian investigators led by Dan Antoniu, having examined photographs from 1910, concluded that the rotary compressor featured at the exhibition was a hybrid between the one described in the initial 30th of May 1910 patent and that shown in a later patent application. They felt that the exhibition machine had a simpler director system, a different rotor with a smaller intake cone, and that the exhaust gas heat transfer system had not been implemented. According to Gerard Hartmann in his dossiers Historiques et Techniques Aeronautiques Françaises, the propulsion system generated only 170 N of thrust, and to generate enough thrust for the aircraft to take off, Coandă would have had to spin the turbine at a speed of 7,000 revolutions per minute with the risk of it exploding. This was not tried, but Hartmann concluded that the experiment proved that the solution worked perfectly. Henri Coandă, writing for L'Aeronautical magazine in January 1912, recalled the previous exhibition's machine as the chief attraction of the 1910 Salon. He wrote that Coandă answered his pressing and indiscreet questions about the turbo-propulsor-powered aircraft at that earlier exhibit, telling him that the machine had attained a speed of 112 km per hour during several flight tests. An improbable answer about which Coandă reserved judgment, waiting for confirmation that never materialized. Related developments. The additional turbo-propulsor patent application 13.502, dated 3 December 1910, was implemented on a double-seat motorized sled commissioned by Cyril Vladimirovich, Grand Duke of Russia, with the help of Dispidals, a boatmaker, and the motor manufacturer Grégoire Coandă supervised the building of a motor sled, powered by a 30-horsepower Grégoire engine driving the turbo-propulsor. The sled was blessed by Russian Orthodox priests at the Dispidals plant near Paris on the 2nd of December 1910. Starting the next day, it was exhibited for 2 weeks at the 12th Automobile Salon of France, alongside Grégoire-powered automobiles on the Grégoire stand. A number of automobile and general interest magazines published photographs or sketches of the sled. This was the second time in the autumn of 1910 that a version of Coandă's turbo-propulsor design was shown at the Grand Palais of Paris. One of the periodicals reported an expected speed of 60 miles per hour, but no account exists of the sled being tested. Coandă continued to work on the Coandă-1910 project at the beginning of 1911, aiming to improve stability, increase the power of the turbo-propulsor, and to implement airfoil improvements. He applied for new patents for aerodynamic investigations and improvements of the Coandă-1910. Coandă described a different, more sturdy system for the attachment of the wings, which also enabled changes in the angle of attack and the center of gravity. He aimed to obtain more power from the propulsion system, and design drawings show the arrangement of 2 air-cooled rotary engines on the sides of the fuselage. The placement of the engines indicates that Coandă did not intend to inject fuel into the jet stream and ignite it, as the cooling of the engines would have been compromised. The patent was annotated with an additional claim on the 19th of July 1911, which brought significant changes, including the addition of retractable landing gear with dampers inside aerodynamic fairings with skids, removal of the horizontal stabilizer, whose supporting surface was provided for each engine, and their accessories were covered to improve aerodynamics. Though Coandă continued to study rotary propulsion mechanisms, Antonio believes that Coandă never implemented a practical solution because of the lack of funds. In May 1911, Coandă filed English-language patents on the turbo-propulsor design in the United Kingdom and the United States, as well as a second French-language patent filed in Switzerland, and he described it for the 1911 publication of L'Annuaire de l'Air, the very expensive project of 1910, costing Coandă about 1 million francs, left him with limited funds. The possibility of a new contract with the French government led Coandă to build the Coandă-1911. He wished to win an army-organized competition at Reims in October, one that required 2 engines in each aircraft as a fail-safe strategy. At the Third Aviation Salon in Paris 1911, Coandă displayed a scale model of the aircraft, which used 2 gnome rotary engines mounted back-to-back, connected by a bevel gear to a single 2-bladed propeller. The strange combination of 2 engines connected to one propeller was originally intended to drive a new turbine, but Coandă was unable to fund one. During trials, the assembly did not provide enough traction and a 4-bladed propeller was ordered. The mounting support of the engines, initially intended for a jet propulsion version, was not adequate for the new configurations of the forward chassis, had to be modified. Henri Coandă, writing for L'Aérophile magazine in January 1912, said that the new 1911 aircraft retained the fuselage, the frame and the wing of Coandă's 1910 design, but did not keep the turbo-propulsor or the wooden wing-loading surface, including the forward longitudinal ribs. The aircraft was flown on the 21st of October 1911, but with modest results, as the latest modifications, especially those related to the power plant, did not compensate for the increased total weight of the aircraft. At the military contest, it did not meet the requirements requirements for independent operation of each engine. Following the 1911 exhibition at the personal request of Sir George White, Coandă moved to the United Kingdom to take a position as chief engineer and chief designer at British and Colonial Aeroplane Company for a few years. In the next 4 decades, Coandă worked on a great variety of inventions. During World War II, he revived his earlier turbo-propulsor engine when he was contracted by the German Army in late 1942 to develop an air propulsion system for military ambulance snow sleds much like the one made for the Russian Grand Duke. The German contract concluded after 1 year, yielding no plans for production, though Coandă had experimented with a variety of nozzles, and said that he had achieved a degree of success. No turbojet engine-style fuel injection or combustion in the airstream was attempted. Coandă and his 1910 aircraft were absent from much of aviation literature of the day. None of the annual issues of Jane's All the World's Aircraft ever mentioned the Coandă 1910 or its turbo-propulsor power plant. As well, the Soviet engineer Nikolai Rynin made no mention of Coandă at all in his exhaustive 9-volume encyclopedia on jet and rocket engines, written in the late 1920s and early 30s.